All right, today we start chapter 10, which looks at another way to measure angles. And the other unit for an angle measure is radians. So to define a radian, right here, 1 radian is the measure of the central angle that intercepts an arc of the circle. So here's the central angle right here. That central angle intercepts this arc, because it cuts it off there and there. And if that arc is equal to the length of the radius of the circle, then that angle measure is 1 radian. So that is the definition of 1 radian. Let's look a quick little applet on Wikipedia, which is pretty cool. It's down here. Whoop, there's the radius of the circle. Then the applet takes it and bends it along the arc. That angle in green is 1 radian. Now they're going to increase it to 2, and then 3. Notice it falls just a little short of the 180, and if we stretch it to 180, it's pi. Let's watch that again. It's pretty cool. There's a radius of a circle. We're going to take it and bend it along the arc. That radius lying on the arc cuts off an angle that is 1 radian in measure. A little less than 60 degrees. And then pi radians goes all the way to 180. So a radian is just another unit for angle measure. And as you saw, you can find that on Wikipedia. The measure of the angle can be expressed in radians or in degrees. Today we're looking at radians. And to convert between radians, we're going to use that relationship that 180 degrees was equal to pi radians. So that's like saying 1 foot equals 12 inches. We are measuring the same thing. We're measuring an angle. We're just using different units. So we're going to practice going back and forth from radians to degrees, and then down below we're going to do degrees to radians. So in order to do this, we need a little rule. And there's 2 ways actually to do this. One, you could just remember, if you have pi in your radian measure, you could substitute it with 180 degrees. So these first few, I can do that. Pi divided by 2 radians is the same as 180 degrees divided by 2, or 90 degrees. Pi divided by 3, substitute 180 degrees, and we get 60 degrees. So pi divided by 3 radians is 60 degrees. One more like that. Substitute in. Pi equals 180 degrees. And this one, you're going to have 135 degrees. Okay. So these radians over here are equal to these degrees over here. Another way to do these, and this way is useful if you don't have pi in the question, like this one and this one. If you don't have pi in the question, then you want to multiply by 180 degrees divided by pi. So think about what you're doing there. When you use that, you're given radians. You multiply by your degrees, 180, over your radians, which is pi. This is really, 1 in disguise. And the radians unit reduces out, and you're left with degrees. So that makes sense when we're converting 2 degrees. So let's try that method for the rest of these. Negative 2 pi divided by 3, we're going to multiply 180 degrees over pi. And this way, the pi radians cancel out. And we just have to do the rest of the arithmetic. I do some of this in my head. 3 goes into 180 60 times, and we end up with negative 120 degrees. Let's circle these. 5 pi divided by 6, using the method of multiplying. We want our degrees on top. We're converting to that unit. And again, 6 goes into 180 30 times. We have 150 degrees for that one. And the last example with pi in it. Into 180. You could do these on your calculator as well, but try and see how nice they are to just reduce by hand. 330 degrees there. These last two, notice, they're radians. So I'm telling you they're radians. They might have a little r next to them like that to say 3.89 radians or negative 1.02 radians. Now these, I cannot use this method because I can't substitute for pi. So here we have to multiply by 180 degrees, and then we're going to divide by pi. On our calculator, the pi symbol, you'll find it right above the caret button. So there's a caret button right underneath clear, and above that is pi. So you're going to hit second caret. Find that on your calculator. We want to use the exact, as close as we can to get the exact value. So 3.89, hit 3.89 times 180, and then hit divided by, and go find that pi value. And you should have approximately 222.9 degrees. Try the next one. Take negative 1.02 radians, multiply by 180, and divide by pi. On your calculator, you should have about negative 58.4 degrees. I'm rounding to the tenths place. And that makes sense because 1 radian is approximately 58 degrees, somewhere in there. So that makes a lot of sense. So try a couple on your own. We'll check them in class tomorrow. I'd like you to try 3 pi over 5 and 5.2 as your radian measures, and convert those to degrees. All right, so let's say we have degrees and we want to convert to radians. So this rule, since we're converting to radians, we want radians on top. So multiply by pi radians over 180 degrees. And again, what are we given? We're given degrees, and we're multiplying by something that has radians on top over degrees, and our degree units will cancel and leave us with a radian measure. All right, so 270, let's use our method, times pi over 180. 225 times pi over 180, negative 300 times pi over 180. Notice you can already see the degrees. Boom, boom, they're canceling. Okay. And here, 150 times pi over 180. You're going to want to reduce these fractions now. You want them in simplest form in terms of pi. So 270 over 180 reduces, divide by 9 on top and on the bottom, 3 pi over 2 radians. Moving down, 225 pi over 180. You can actually put 225 over 180 in your calculator. Hit enter, and then remember our good old math frac. We'll make a nice fraction out of that if you'd like. Leave your answer in terms of pi. And you should have 5 pi over 4. Negative 300 degrees. Let's see, we can divide by 10, and 6 goes into both of those. So negative 300 degrees is the same as negative 5 pi over 3. And 150 pi divided by 180. 3 goes into both of those. 5 pi over 6. So that's lots of practice. On your own, I'd like to have you convert negative 240 degrees and 100 degrees to simplest terms in terms of pi. Leave pi in the answer there. Okay. On the next page, they'd like us to find the angle in degrees, so we're going to convert again. Then draw the angle in standard position, and then we're going to find the reference angle. And we're going to find that reference angle in terms of degrees and radians. You want to start to get a sense, the unit circle, where we used to have degrees going around, so 0 degrees, 90 degrees, 180, 270, and 360 again. That in terms of radians, that's 0 radians. We saw on the graphic that's pi. Halfway is pi over 2, which was 90 degrees. And at the bottom we have 3 pi over 2. You could think of this as 0 pi over 2, 1 pi over 2, 2 pi over 2, and 3 pi over 2, if you'd like. Then everything's over 2. So let's get started here. 7 pi over 3. First we're going to convert it. So we're going from radians to degrees. I've got 420 degrees. In standard position, that angle swings around more than once. You might want to know in advance how much more. That actually helps you with your reference angle, doesn't it? So if this hits here as its terminal side, then the reference angle is right in here. That reference angle is 60 degrees. And that is equivalent to pi over 3 radians. Okay. Negative 5 pi over 4. First converting. That's a negative angle. Negative 225 degrees. So we go clockwise. Oops, didn't mean to do that. A little bit. And right there. These arrows are the 45s. It's not very smooth. Try that So you can see then the reference angle, always with the x-axis, is just this little part. So the reference angle is 45 degrees. And all of our 45s have a 4 on the bottom. This is pi divided by 4. If you want to confirm that, take a look at 180 degrees divided by 4, and you should get 45 degrees. And the last one, I believe this says 5 pi over 6 on your papers. Reduce the pi, that goes at 30 times. Again, you could do it on your calculator, it's going to take you longer. You should know how many times 6 goes into 180, and you should know how many times 3 goes into 180. It's a 150 degree angle, so we are just a little bit short of the x-axis here. Our reference angle with the x-axis, remember reference angles are always with the x-axis, would be 30 degrees, which is pi divided by 6. All right. So it's a lot of converting. You need to be very good going back and forth, converting degrees to radians and radians to degrees. And now the last part of the lesson has to do with arc length of a circle. So if I take and cut off an arc of this circle, and a circle with a radius r, and a central angle in radians of theta, then this arc has length s. So we have a formula that you'll want to put on your formula page. S equals theta r. Just remember, theta must be in radians. So let's go through these quick little examples. Write your formula each time. It'll help you. If you see the word arc length, it's this formula. If you see S and R and theta, it's this formula. So we have 6 equals theta times 2. Looking for theta. Theta is 3. If theta equals 2.5, S is 50, find R. So we have 50 equals 2.5 times R divided by 2.5. And here we have the radius of the circle is 20. These are pretty straightforward questions. So the word problems we'll want to spend a little more time on. If r equals 0.8 and theta is pi over 4, find s. Always write your formula. Put it on your formula page right now. S equals pi over 4 times 0.8. All right, that is, we could do this a few different ways. I'm going to multiply top and bottom by 10, so I get 8 pi over 40. Not loving that decimal. All right, and then that is pi over 5. And you might have had 0.2 pi as well. Pi over 5 is 1/5 pi. And that's the same as 0.2. Let's look at a couple of word problems. A wheel whose radius measures 16 inches is rotated. So this wheel is rotated, and obviously wheels turn if a point on the circumference of the wheel, so that's the outside, moves through an arc of 12 feet, there's your S value. And as soon as I'm writing it, I notice do not have the same units here. So I'm going to convert the feet into inches. There we go. Find the angle through which a spoke of the wheel travels. So we're looking for theta. Divide by 16. And we have 9, and we know it's radians. 9 radians. All right, so our last question is a clock question. Through how many radians does the minute hand of a clock turn in 45 minutes? So 45 minutes, our clock hand would be traveling that distance, right? Which is 270 degrees of the circle. So we can practice converting 270 degrees because they want radians, pi over 180. I think we did that one sooner, or earlier rather, sooner. 3 pi over 2 radians is what that converts to. That was on our unit circle also. But if the minute hand is 5 centimeters long, so they're giving you a radius of the circle. How far does its tip travel in 45 minutes? So we already figured out that 45 minutes makes an angle in radians of 3 pi over 2. And the tip traveling would be the arc length. So the tip of this minute hand travels, and that's your arc length on the outside. Okay, so we're looking for that. Let's write the formula down. We've got our theta, and we have our radius of 5. And so we have 15 pi over 2. You could leave it like that, or you could say 7.5 pi. If the question wanted you to figure out to the nearest centimeter, the unit would have to match the radius as well. So the nearest centimeter, then you could do 7.5 times and find that pi value on the deck of your calculator again. And I've got approximately 23.56 centimeters. I rounded to the hundredths place. Okay, that's it. Radians. Radians are used to measure angles. See you tomorrow.